Hello 20-2 students. So today we are looking at lesson 4.3. This is part 3 of this section. So today we're looking at rationalizing the denominator, and there will be one more lesson in this section which will be using the conjugate. So we're just getting into increasingly more complex types of expressions, I guess, or radicals, and learning how to do our operations with them. So in simplified form, radicals should not have a radical in the denominator. Okay, so when we did our lesson last time, notice that for all of our solutions, like here we have just a whole number. This one doesn't have a denominator. We've reduced it so it's not a fraction anymore. So that one's okay. And then same thing with this one. However, if you were to do those same set of steps and your final answer had a radical in the denominator, then you would want to use something that we call rationalizing the denominator, which is basically just an operation that gets rid of that radical in the denominator. So essentially, if you're doing division, you can always go through first of all and try to complete the steps that we did in the previous lesson. If you get to the end of those steps and you find that you have a radical in the denominator, then you want to turn towards this method that we'll look at today, which is rationalizing the denominator. So a couple of things to remember as we work through this is multiplying any fraction by 1 doesn't change its value, just like any other value, right? If you multiply it by 1, it doesn't change it. Also, any expression divided by itself is equal to 1. So like 3 divided by itself, which is 3, is 1. Same thing like root 17 divided by root 17 is equal to 1. Okay, so no changes there with either of those things. And so those are some things that we can keep in mind as we work through this rationalizing. Steps for rationalizing the denominator: if possible, simplify and divide. So always see if you can do that first. If you can't do that and you have a radical in the denominator, then you want to multiply both the numerator and the denominator by the radical that's in the denominator, which is going to essentially eliminate that denominator from the bottom. Wait, did I just say that wrong? It's going to eliminate the radical from the denominator. Once you've done that, then you, of course, always want to simplify as much as possible again. So let's give this a try. So in the first one, we have root 5 divided by root 2. If we were to try and divide that, 5 divided by 2, remember from last lesson, we could go like this, 5 over 2. There isn't any whole number division there. So if we were to leave this as is, we would have a radical in the denominator, which we don't want to have. So in order to do that, in order to get rid of that radical, we want to multiply this whole radical by the radical that's found in the denominator. So it's going to be multiplied by root 2 over root 2. Remember your rules for multiplying radicals. Basically, you just multiply the radicand. So root 5 times by root 2 gives us root 10. And root 2 times by root 2 gives us root 4. Now we look at our answer here. Can we simplify 10 any further? There's no perfect square in 10. 5 times 2, you can't simplify those anymore. But root 4 is 2. So our final answer should be root 10 divided by 2. Okay? Let's try another one here. So what we'll find with this one, same kind of a deal. 20 and 3 aren't going to divide evenly into each other, and 3 can't be simplified any further. So we're going to have to use rationalizing the denominator in order to get rid of that radical in the denominator. So that means we're multiplying this whole term by root 3 over root 3. So root 20 times by root 3 gives us root 60. Root 3 times by root 3 gives us root 9. Square root of 9 is 3. Okay, so I kind of skipped a little bit of a step there. Now what we want to do, we have root 60 divided by 3. Can we simplify root 60 at all? So if we factor out 60, I don't know, let's just make it easy. 10 times by 6, and 10 factors into 5 times by 2, and 6 factors into 2 times by 3. So if we look at the end of our factor tree here, we have one pair, which is a square. So 5 times 4 would be 20, times 3 is 60. So that's another way we could have factored this. So we can pull that perfect square out and make this into a mixed radical. So 2 is going to be the coefficient. Root, what's left in there? 5 times 3, 15. And then on the bottom, we're going to have a 3. Can we divide these values into each other? No, 2 divided by 3 is just 2/3. So that's our final answer. Okay, no more simplification. In this next one, 3 root 12 divided by root 72. It's kind of hard to tell right away, right? Like with these ones, we know we can't simplify root 3 anymore, but with these ones, we want to try and factor them down first because it's hard to tell maybe right away if 12 and 72 will divide evenly into each other. So let's do what we did in the last lesson and work through our first steps of division. Our coefficients are 3, and even though it's not written here, it'd be 1, so 3 over 1. And then underneath our radical, we're going to have 12 over 72. Now, values that fit into both 12 and 72, 6 goes into 12 twice and into 72 12 times. So 2 and 12 can be reduced then into 1 and 6. So the other way to say that would be 12 goes into 72 6 times. So if we reduce that, we end up with 3 over 1 root. 12 goes into 12 once, and 12 goes into 72 6 times. So now we have this set up. Remember, our next step is to bring this back into this kind of a setup here. So we're going to have 3 root 1 on the top, and 1 root 6 on the bottom, which is just root 6. So 3 root 1 divided by root 6, we have simplified as much as we can. Nothing else can divide out, but we still have a radical on the bottom, so we want to get rid of that. This is where we need to step in with rationalizing the denominator. So we see that we have that, so we're going to have to multiply both by root 6. 3 is, there's only a coefficient of 1 there, so 3 will stay the same. Root 1 times root 6 is root 6. And then on the bottom, root 6 times by root 6 gives us root 36, and the square root of 36 is just 6, right? So anytime you multiply square roots by each other, you just end up with the radicand on its own. Now, you might think you're done, but we do want to always check one more time, will anything divide out? Well, 3 divided by 6, it doesn't divide out, but it can simplify. 3 can be divided by 3, and so can 6. So our final answer would be 3 divided by 3 is 1. We don't write a coefficient of 1 ever, so it's just going to be root 6. 6 divided by 3 is 2. And there's our final answer, root 6 divided by 2. I think this pen might be running out of steam. Let's try another one. Okay, so last one here. Ooh, you know what, guys? I'm starting to run out of space on here, so I might grab a fresh piece of paper. So we have 3 root 18 minus root 12 over root 2. So again, we start out with something fairly complex, although we can see right away this one is not going to be able to be simplified further. So it is going to be something we're going to have to eliminate. But before we do that, we do want to, just like we talked about in the last lesson, if you have mixed radicals, see if you can simplify them any further. So in this one, or even if it's not mixed radicals, because this is an entire radical that can be simplified further. So maybe we'll build our factor tree here. So 18 is 9 times 2. 9 is a perfect square, right? So if we square root 9, we get 3. So we're going to multiply that by the coefficient that's already there, 3 times by 3. And then underneath the radical, we're just going to have the remaining 2. Minus 12 can be factored down into 3 times by 4, and 4 is a perfect square with 2, right? So we're going to put 2 as our coefficient, and then the 3 stays under the radical. And then on the bottom we have that root 2. So with this, we can't simplify these by combining, so always check that first, but we can't do that. I'll just write this out where I've combined these. So 3 times 3 is 9 root 2 minus 2 root 3 divided by root 2. So I can't go any further with my simplification here. So even if you have like terms here, like in your radicals, you can't go ahead and divide it because remember, this has to be divided by both of these. So what we want to do is rationalize this denominator. So we're going to multiply this whole thing by root 2 over root 2. Okay, so in this case, we have a binomial in our numerator, which is 2 terms, and we need to make sure we multiply both of them by that radical from the bottom. So 9 root 2 times by root 2 gives us 9 root 4 minus 2 root 3 gives us 2, 3 times by 2 is 6, 2 root 6. And then on the bottom, root 2 times root 2 gives us root 4. Square root of 4 is 2. Now simplifying further, root 4 is 2 like we just said, so 2 times 9 gives us 18 minus 2 root 6 divided by 2. Can we simplify that any further? Well, 2 would divide out of 18 and 2. So if we divide this one by 2, oops, and it can also divide out of there. So 18 divided by 2 gives us 9. 2 divided by 2 is 1, so it's going to be 9 minus root 6. And we've divided the 2 by both of the terms to cancel it out. So there's our final expression, 9 minus root 6. Okay, so pause the video now. Give a couple of those a try yourself. You want to make sure that you're familiar with these simpler ones. The ones that I've given you are all kind of more simple, not like that last one that we did. Give those a try because we're going to try a few more of these more complex ones so you guys can really get the hang of it before I give you those kind to work on for yourself. So give these ones a try. Make sure you're really comfortable with it. Check your answers there. And then after that, you can unpause the video and we'll do 2 more kind of these more complex style of question. All right, so in this first one, we have 4 root 12 minus 10 root 6 over 2 root 3. Same thing, we want to factor out what we can to simplify first. So 12, we can simplify into 4 times by 3, and we know that 4 is a perfect square, so if we square root that, we'll get 2, which we want to multiply by that coefficient. So 2 times by 4 gives us 8, and then underneath the radical, we're just left with that lone 3. So 8 root 3 minus 10 root 6. 6 factors down into 3 times 2, but there's no perfect square to pull out of there, so we can leave that as is. And then on the bottom, 2 root 3, again, no simplification possible there. Okay, so now what we want to do is rationalize our denominator because we still have that radical in there. So in order to do this, it's a little bit different than the question we did on the previous page because now our denominator, the radical that's in our denominator, has a coefficient. We are only trying to get rid of the radical part of that. So when we rationalize the denominator, all we have to do is multiply it by the radical component of the bottom term. So we're going to multiply everything by root 3 over root 3. And that's going to give us, we're going to have to make sure we multiply everything through, right? So it's going to be 8 root 3 times by root 3. So that's going to give us root 3 times root 3 is root 9. Minus 10 times by root 6 times root 3 is root 18. And then on the bottom, 2 root 3 times by root 3 is going to give us 2 root 9. So now we can look at simplifying really quickly with our radicals. So basically, if we have a mixed radical that we can simplify, we want to do that. Root 9 is just 3, so 3 times 8 gives us 24. Minus, let's see, 18 is 9 times by 2, and we can perfect square 9 to 3. So 3 times by 10 is going to give us, oh, sorry guys, I got confused there for a second. Okay, so 30 root 2, and then on the bottom, 2 times by square root of 9 is 3, so 2 times 3 is 6. All right, now that we have that simplified, we want to look and see if we can divide things out. So looking at this, 6 times 4 is 24, 6 times 5 is 30, so 6 will divide out of both of these. So let's divide by 6, divide by 6. 24 divided by 6 is 4, like we just said. 30 divided by 6 is 5. Root 2, and because we've divided 6 out of both of those terms, it doesn't show up in the denominator anymore. So this is our final answer here. Now, like I showed you guys in the previous lesson, you can always check this in your calculator. It's a little bit more complex, but if you do 4 minus 5 root 2, so 4 minus 5 root 2, we get negative 3.07. If we put in what we had up here, so I would do 4 root 12. I'd hit enter here personally, minus 10 root 6. And then divide that by 2 root 3. And I end up with the same value, negative 3.07. So I can see that this is an equivalent like fraction or term, I guess, to this first one. So I know that I did my calculations correctly. Okay, so just a good way to check if you're on a test. Of course, you still have to show me all of these steps, and your calculator is not going to give you the nice, what we call exact values here. It's going to give you the decimals, so you wouldn't get marks for that on a test. So don't think that you can rely on that. Okay, we have really similar one here, 4 root 10 minus 10 root 6 over 2 root 3. So instead of 4 root 12, just a little bit of a difference there. So let's see if we can simplify anything. 10 is 5 times 2, no perfect squares in there. And like we already said, none in there and none in there. So we have to just start out right away with multiplying by our radical that's in the denominator. So multiply this whole thing through by root 3 over root 3. And so we want to make sure we multiply both of these terms through. So 4 root 10 times by root 3 is root 30, minus 10 times by root 6 times root 3 is root 18, divided by 2 times by root 3 is root 9. Now just see if we can simplify our radicals. Okay, so 30 is, let's see, 10 times 3, none of that is going to be a perfect square, so we can't actually factor that one down anymore. But like we saw in the previous one, 18 is 9 times 2, and 9 is our perfect square, so that's going to give us 3, which we multiply by there. So 4 root 30 minus 10 times by 3 is 30, and under the root sign, we're just going to have that 2 left. Root 9 is 3 times 2 is 6. So now in this one, 6 does not divide into 4, even though it does into 30. So we need to find a different value that can divide into all of these 3 terms. The only one that I can see would be 2. So we can do 4 divided by 2, 30 divided by 2, and 6 divided by 2. So in this case, we're more just simplifying the fraction, right? We're not actually just doing the division. So 4 divided by 2 is 2 root 30, minus 30 divided by 2 is 15. Oh, whoops, 30, not 3. Sorry, guys. Okay, 2 root 30 minus 15 root 2. And we're going to divide that by 6 divided by 2 is 3. Okay, we've simplified as much as we can, so there's our final answer. And of course, again, if you want, you can use your calculator to check this one against that one, and you should get the same decimal value. So that is rationalizing the denominator. So your assignment is down here. You can try a few of those and get some good practice in before we move on to the next lesson, which is working with the conjugate. Working with the conjugate is very similar to what we did today, but it's going to involve a denominator that has two terms in it. So far, we've only looked at denominators with one term in it. So again, we're going to move a step more complex in our next lesson. So I will see you then.